Hello, everyone. What we've got, the project on which we are working right now in Krakow University is Holographic Med Assistant. Basically, it's an idea where we would like to extend the work of the doctors with something new. What I mean, ba- uh, let's look at doctor work and let's say IT specialist. The IT specialist, the guys who working with the computer, sometimes needs some help. For example, to just check the servers or some application, and they can always count that they will be able to connect remotely to some colleague who has bigger experience and just show him exactly everything, let him access the server or the computer and just work on it. The same we would like to achieve with the doctors. So when you've got a problem during some medical treatment and you would like to review it with some other doctor, you are right now allowed to use, let's say, cell phone, or we can use the video conference, and that's mainly all. You cannot touch, you cannot see something from the different perspective. You're very limited to what the person who calls you back ask you and show you. So uh, we are going in two directions. First is the on-site treatment with the doctor who's trying to solve the mystery sickness of the patient, and second one is we want to learn new young doctors with the treatments that they cannot see because, let's say, they are in small city where there is not really a lot of such cases, and they are really limited to learn something very specific. So what we've got right now, when we are using the camera or video conference or the phone, we are always limited to two-dimension view. We are not able to see what's on the left side, the right side of the patient. We can only see in two dimension, and only if we ask the person on the other side to move the camera somewhere else, we are able to see something more. Uh, Also in the hospitals, when we've got the patient who's lying or during the operation, we can be limited to more than one perspective, because we can have on the surgery 2 3 cameras using which we can switch between them and just see the operation from the different perspective, but it's still limited to where the camera is placed and what camera is seeing right now. So our goal is to see more, see everything what camera is not seeing, because basically, even if you've got an operator during the surgery, let's look at on this surgery example. We've got operator who's during entire process and walking around trying to see as much as he can and record it so you can remotely see it. It's really difficult because not always the person who's the operator who's recording the video really knows what should show you and what you would like to see, and what's important. So the perspective from which camera is looking at the operation or the treatment is really important. We would like to use it also in the way that we will be able to navigate the doctors in case there will be some strange behaviors during the surgery, and there will be some problems that they were never seen by such doctor, and he would like to just get someone in touch and be like remotely navigate with someone who already had similar case or similar problem during his surgery. So what we are using two devices, Microsoft HoloLens and Microsoft Azure Kinect. First one is the augmented reality goggles. Those are the glasses where there are displayed 3D models, and the glasses are also analyzing entire space around you, so they are able to create a model in front of you and leave it in the same place. So for example, when you turn on the goggles standing in front of your table, you will display, let's say, the heart, and you can walk around the table and the heart will always stays in the same place, rotated, let's say, front to the door, and always will stay like that. So you can watch it like it would be hanging above the table and look it from the different perspective. You can also take it using the hands, because the glasses can notice your touch, how your manipulation with your hands. So for example, you can take two objects and put it close to each other, rotate them, change size, go inside the object, see what's inside the heart, see how does it react, etc. But to have those models and have exactly everything what I'm saying, so you are able to see what's inside and walk around the heart, you need to record it in some way. So here we comes with the Azure Kinect, the cameras, which are not simple cameras, because they've got, from what I remember, three separate sensors which are recording the space. And they are creating, they are able to understand not only the two-dimensional view, but they are able to scan entire space and tell you that when you record, for example, table and lamp standing on it, it knows how far is each part of the table from the camera with the millimeter distance, and able to tell you how far is the lamp and what's the shape of the lamp. And using the specially dedicated algorithms, we are able to create from those data the 3D models. The only problem is that sometimes the cameras are not able to see something what is behind the object. So, for example, when we record the model, the person standing in front of you, we are able to record and create model of entire human space from his front, but we are not able to create it from the back. So here we are using 2, even 3 cameras to connect everything what camera see in front of the person, and everything what it sees from the back of the person, and then connect those 2 views and create one simple full with the details object of the human. So here's the view of the solution which we would like to do. So using, for example, 2 cameras, we are recording the entire operating room. The same view is remotely over the internet transferred to the people standing in completely different location with the HoloLens on head, and they are seeing on the table exactly everything what is happening in the operating room. They are able to see the hands moving, everything what camera, a 3D camera is able to scan and generate. The best thing in that idea is that you are able to be on the operation, walk around the table, see from every perspective you want in live, in real time, and ask the questions the persons on the other side in the real operating room. And also you can mark, for example, on the models, on the 3D model, that, hey, I don't understand, there's something happening here. You just point with the fingers on this 3D model, and in the same way, the same mark comes up on the operating room, and person who's doing the operation can be assisted by the remote user by pointing him, hey, look here, change here something, you should do this by that. Yeah. Something like that. It's better to understand it, because those slides not really show everything what I would like to show you. Let me try to share my screen, and I will try to show you the short movie, which is showing the view recorded just from one camera. It's an operation done in Krakow, and you can see 6 different angles created from just one 3D camera. And on the right top corner, we can see how we are rotating the space in real time. Everything is synchronized. Those are the one and the same operation in the same second. The black parts are the places which camera didn't see because it's behind the people. This is why we will be using the second camera to map just everything what is missing. It's in colors because we decided it's better to just show you the depth. Because if I show you like in the middle of the top of the screen, the normal view like that with generated model, you will not really see that this is really a 3D model. You can see also on those views that people are manipulating, doing some treatment with the fingers, and everything is tracked very precisely. You can see that those movies are created from the points. This is the cloud point. So every thing what camera creates is like shooting with the laser. That's simply just to understand. So shooting everything with the laser and reading how far that point is from the camera, and by that creating such model. Later, we can take the color entire graphic from the normal, from this middle bottom view, take entire colors of the hats, etc., and place it on those 3D models. And this way, we achieve the real 3D model with everything what we would like to see. Like on the right top corner, you see that we are rotating, and the same view we would be able to achieve in the HoloLens. We are displaying the operation in, for example, empty room, and we can walk around, stand in the place where the surgeon is doing something, and just look from his eyes what is exactly he's doing and how doing some treatment. Also, we would like to, as I said earlier, we would like to remotely assist them. So we would like to, using the HoloLens, remotely send them advices, point something out on the surgery, and just assist them. So that would be much better than just the normal video view. We are right now waiting for more cameras because we've got just 2 devices so far. They are very limited. There is very limited access for them in the entire world. So we are just doing the test with 2. We are expecting to test it even with the 6 cameras and even 10 HoloLens in the same time.
Excuse me?
Yeah.
May I ask you a question according to the video?
Yeah.
I know I'm interrupting, but I was wondering about the accuracy of colors. Because during surgery, colors of the intestines, so to say, are quite important.
Yeah, but the view which you are seeing here with the colors is just the distance from the camera. We use it to create like skeleton of the 3D model.
Yes.
Next, in the second phase, I don't remember, do I have something like that? We are placing those colors and everything one-to-one on those models. So if I've got here in the middle hand of the person, I'm placing this color and the entire structure, the texture, on the hand of this 3D model. And this way we achieve great view, great real 3D model. And yeah, I totally understand your point that the colors and everything is important, and that's our goal, and it's really working like that.
It's working, okay.
Yeah, exactly. Like this. I'm trying to check, do I have something like that to show you also with those 3D? Because it's we already had like few operations so far where we use those cameras. I think no, sorry. Okay, that's basically everything else is on our server, so I cannot download it so quickly. Yeah, that would be all. That was a quick one, but that's all from me. Thank you.
Well, it's looks great, to be honest. Why those cameras are limited? Why the amount of them is limited?
there is a problem with electronic devices, and everything which is electronically is really right now limited because of the COVID, and factories were closed. So
Okay. Mm-hmm.
for example, those cameras which we already have too costs $350, not a lot, but right now we don't know when they will be available. And on the eBay, for example, you can buy it for 4 times more. So it's crazy. It's just
Ooh,
crazy because the electronic goes up and up every day. It's
right.
just
Now, I was wondering whether it's the COVID-related shortage of supplies or something else.
no, COVID, exactly. That's COVID. They locked everything, all the
Yeah,
manufacturers, and just didn't produce everything. And right now, you can see it in the markets in the Germany, for example, where the cars are standing on the parkings, and they are not able to supply it with electronics. With the,
yeah,
yeah,
I know.
it's everywhere like that.
Amazing. And what other applications you see for this holographic med assistant? I understand the medical application, but also maybe the some. Do you know any other applications where this technology is being used?
Yeah, it's already we've done 20 let's say training applications for the medical students in university in Krakow, where students are wearing the glasses and for example learning about the different kind of tumors, about problems with teeth, etc., where they are playing with the models. They are able to take for example computer tomography 3D model and just review it, go inside it, take it apart, everything using with this holography technology.
Without the need to cut the real person.
Yeah, exactly. That's the biggest wow in the this technology is the anatomy, where we are displaying the students' entire human anatomy, and they are able to watch it, change it, rotate it, take apart. You want to see what's behind the liver, you take it out. You want to see what's inside the liver, you just place your head inside the liver, and that's just amazing.
Oh. Sounds, yes, interesting, so to say.
Yeah, they're really and really fun. Everyone who learns, I spoke with some different professors and showing them this, and they said, "Oh my God, that's brilliant! It's different from what we learned a couple of years ago when we had only 2D dimensions or what we could see on the computer. Right now, you can really even touch it in some way. Those organs."
Amazing. Wow, great. Well, thank you very much for this presentation and virtual as well. And looks very, very promising. And I hope this supply shortage will end up soon.